What's up everyone, welcome back to PythonDevOps. Today we are starting a brand new series, AWS Networking, and we are starting from the very foundation, VPC. In this video we are covering VPC fundamentals, subnet, route table, internet gateway, net gateway and security. And in the upcoming video we will go deeper, like VPC pairing, transit gateway, direct connect and many more. This series is going to be your go-to reference for AWS networking. Alright, let's get started with the VPC. So what is VPC? VPC stands for Virtual Private Cloud. Is logically isolated section of a cloud provider network where you can launch resource in a virtual network that you define. You have full control over the networking environment, IP ranges, subnet, route table, gateway and security setting. So this is your VPC I have given. We have a AWS cloud. Inside that we have choose the region, that is AP South 1. Then we have a CIDR value. In the CIDR value we decided two different availability zone. One is availability zone A and second one is availability zone B. And we have created the multiple subnet like public, private in each availability zone. And then we created our AWS resources like EC2, ALB, app server in both the availability zone and according to the our subnets. So let's go into the Chrome. Here I created the nodes as well. This is a theory part. I will explain it later. Let's first understand this VPC architecture. So first we have created the AWS cloud. Inside that we selected the region. For that we have selected the US East one. Inside that region we have created a VPC. VPC is just virtual private cloud. VPC like you own private network inside AWS itself. Inside that VPC we have divided the network into two availability zone. This is availability zone A, this is availability zone B. We do this for high availability. So even if one AZ goes down, the other is still working. Now inside each AZ, we have two types of subnet. This one is public subnet and this one is private subnet. Public subnet are used for resources that need internet access directly, like load balancer or Bayesian host. You can search the SAP here, like I have searched for the RDS. You can search for the load balancer. You can use that tool. Most of the DevOps use that tool. So I have selected this icon. So I got the load balancer icon. Let's minimize the size because our diagram is so small, and give the small name like ALB. And you can create into the public subnet. You can create into any public subnet according to your configuration placed here. So we have a ALB into the public subnet. And which service you do not want to expose on the internet directly, you can create into the private subnet, like your database or application server. You can create into the private subnet. So I have searched for the RDS, and you can place into the, give the small size and give the small name like I give the RDS, and you can place into the private subnet. So that's how you set up your secure infra. Now look here into the public subnet. Inside the public subnet we have a NAT gateway, and this NAT gateway is connected to the internet gateway, which is attached to the VPC. So this internet gateway is attached with the VPC. Internet gateway is the entry and exit point to the internet. And one more important thing is subnet is associated with the route table. Route table decide where the traffic should go. So overall we have a VPC, then we have a multiple availability zone, then we have a public and private subnet for separation, and then we have a net gateway for private outbound access. Then we have a internet gateway for the internet connectivity into your VPC. Then we create the route table. Now we create the route table. So if you look at the diagram, you might be wondering where exactly is the route table. I don't see like it. Net gateway is there, internet gateway is there, but route table is not a physical resource. It's a logical component that is attached to a subnet. So instead of placing it somewhere in the diagram, we associate with the subnet. Now let's understand with our architecture. First we have a public subnet. Every public subnet is connected to a public route table, and inside that route table we define a rule with the internet gateway, that is IP we provide 000 4 times 0/0. It means any traffic goes outside the VPC will go through the internet gateway. That's why these subnet are called public one. Now let's talk about private subnet. So private subnets are connected to a private route table, and here is the rule. You provide the 4 times 0/0 via NAT gateway. So now what happened? Instance inside private subnet cannot directly access the internet, but they can go out using the NAT gateway, and that's why it's called private subnet. So this is about the route table. Now let's go to the theory part. So these are nodes, and what is the table of content? What is VPC, CIDR IP ranges, subnet, route table, NAT gateway, everything. So I've already explained what is VPC. VPC is your virtual private cloud, which isolate private network inside your AWS. It's think like your own data center inside the AWS, which I have also shown in the diagram. Inside the AWS, we have a VPC. Key characteristics: you can isolate no access unless you allow it. You can remove the internet gateway and it has no internet access. No one can access. It is region wide. You can see I have created into the region. We have a subnet. Subnet are the AZ specific. Like this one is created into the US East 1A, and these subnets are created into the US East 1B. So subnets are the AZ specific. And most important thing, it is free to create. You pay for resources inside it. Like you did not charge on the creating the VPC. You are only charged the resources you have created. Like I have created the RDS ALB, so you get charged onto the resources that you created, and it has the limit 5 VPC per region. So it not required even in the production environment. It require only 2 or 3 VPC. Okay, I have given the basic architecture diagram. It is the same. We have a AWS region, then we have a VPC, then AZ. A has the 2 subnet and it has ALB and EC2. You can create the EC2 as a Bayesian host, and we have a private subnet where you can deploy your application and the DB. Same into the AZB, and top of the VPC we have created the internet gateway. So these are basic architecture. So let's go into our presentation. Next we have a CIDR and IP addresses. So I have created the presentation for it. Let's go into the presentation. So this is our topic, CIDR and IP ranges. Before that I have the VPC. Okay, how to carve up your IP space means you can increase the number of IPs into your VPC. So basic CIDR notations are the 10,0,0,0, then slash you can give till 32 number. So I have provided 16, that is means 2 to the power 32 minus whatever the number is here, that is 32 minus 16. So we got the 65,536 IPs into the VPC. If you provided 24, then you got the 256 IP. If you provided 28, then you got the 32 minus 28, that is 2 to the power 4, that is 16. So you got the 16 IPs. And slash 0 means it is for the anywhere. The standard VPC architecture will be, we provided the VPC slash 16, which is goes like 10,0,0,0 3 times 0 and then slash 16. So we got that IP. Then we have created the 4 route table. 4 subnets. One is public, 2 public and 2 private subnets. 10,0,10/24. That means we got 256 IP in it. Then same for it. Same in case of private subnet. 10,0,11/24. You got 256 IP, and same for the private subnet B. So that's how you can use the CIDR and IP addresses. Next, subnet and routing. We have internet, then we have internet gateway. Internet gateway access into the public subnet, and we give the route table that it has 0,0,0,0/0 internet gateway. It is routed directly to the internet, means your public subnet. Via net gateway, you can attach to the private subnet your route table, the private one, the 0,0,0/0 4 times 0 then slash 0 and the net gateway. So that's how it access via net gateway into the private subnet. So route table basically the logical operator, not the actual resource. So then we have a security group and NACL. I will explain it later. Okay, let me show you one thing I usually do, how to find the CIDR range with the IPs, how much number of IP we get. For that, let's go to the Chrome itself and go into the search for the CIDR calculator. Mostly I use this one, MX tool. You can use any of this, and you can give your VPC IP. So I give 10,0,0,0. See, if you give 32, that is 2 to the power 32 minus 32, that becomes 2 to the power 0. Then we get 1 IP. If you give 2 to the power 31, then you got 32 minus 31, that is 1. That is 2 to the power 1 equal to 2, that we got 2 IP. Same for 29 for 8 IP, 28 for 16 IP, and we are passing 16 IP. So we got 65,536 IP, and the range will be 10,0,0 to till the 10,0,255,255. If you give 10 to the power 32, you got the 1 IP, that is this one only, 1 IP range. Okay, and we can check for the 16 different IP ranges. If you need bigger VPC, you can choose below 1, but for the standard we use 16 basically. If you pass the 10 to the power 28, which is our 24, which is our subnet IP, so we got the 10,0,0,255. After that, if you want to increase the number 1 range, then you got 1 here. So for that reason, in the PowerPoint, I give the 1 here. So we got for the 24, 1 here, and then calculate 10,0,1 till 255. Then you increase to the 2, then we got 2 to 255. Same if you give in the 11, so we got the 11 to the 255. I'm not getting the range there, but yeah, okay. So that's how you can calculate and got the number of IPs. How much will you get? So let's go to the AWS console then. So these are AWS console. Let's click on the AWS and go to the home page. So this is our home page. So let's go our diagram. So first we have to choose the cloud as we have already choose. Now we have to select the region. So let's select a different region. Like you can choose anyone. I'm going with the, let's go with the Ohio region, US East 2. So this is our region. And now let's open the VPC. So we have to search for the VPC, click on it. And by default you got the one VPC in every region. So you can check, it's loading. So we have one VPC, 3 subnet, 0 endpoint, 0 pairing, so one route table also there. So let's create our VPC. This one is default. Create our VPC. So we have a two section, one VPC and more. In one click you got all the thing at one time. Even we got the VPC endpoint for S3. We go there. So we have a internet gateway and the endpoint. I will explain it in upcoming video. But now in this video we are creating just VPC. So select the VPC only. Then you have to give the name. For me, I'm giving demo VPC, and you can give the CIDR 10.0.0.0/16 as I have shown you in the our PPT or the notes as well. So keep it default and click on the create VPC. So our VPC is created, but suppose we have one route and we give that default one. Okay, next we have to create the internet gateway. So VPC is created. Over the VPC we have an internet gateway. So let's go to create the internet gateway. Click on the internet gateway and we have a default one. Let's create a new one. I'm giving the name demo IGW. So we got the default tag as well. Click on the create internet gateway. The internet gateway is created, but here you can show the state. It shows the details and no VPC ID also here. So we have to attach with the VPC. So click on the action and attach to VPC. Then you have to select your VPC. We have created the demo one. So we have selected this one and click on the attach internet gateway. So see, it's attached and it shows our VPC ID as well. Next part, we have to select the AZ and create the subnet inside it. So we are going to create the subnet. So click on the subnet. Default we have a 3 subnet. Let's create our subnet. First you have to select the VPC. It is our demo VPC. It has the side range. Now we have to create the subnet. First we create the public subnet. Give the name demo public subnet 01. Let's copy this name. I'm going to use two different AZ. So we have a 2 AZ here, US East 2A. Select this one and give the default header as I have shown you into the presentation /24. So we give the one here. Next, create another subnet. This is the whole configuration of a one subnet. Same we have to do the 3 times. Click on the add subnet and give the name. I'm going to another public subnet this time and into the different region. First time I've selected AZ1. Now I'm selecting the AZ2 and give the range 10.0.0.0/24. And what was in the presentation? So we will create the same. It was the public one is 10.020. Okay, so give the 2 here. So second public subnet is created. Now create the third, which is our private. For the private, give the change the name to the public to the private. In availability zone, I will create into the 1 and the side range 10.0.110/24. 24. So same as in our presentation 10.0.110/24. Next we have to add one more subnet. Let's copy this name, add new subnet, and these are last subnet. Friends, AZ2 10.0.0/12.0. Is the one dot here. All the subnet is created. Now click on the create subnet. So 0. 2 7 I missed the 0. Now it's correct. Click on the create subnet. So if the calculation is not fixed, so it shows the error, so you have to calculate accordingly. Our 4 subnet is created, 2 is public and 2 are private subnet, and they are in public one into the separate availability zone, same for the private one. So let's now we have to, what is the next? We have selected the AZ, we have a US is 2A and 2B, and we have created the subnet. Now we have to map the network. So the question is, VPC know which one is public and which one is private? Answer is in the diagram. Public has the direct internet access via the internet gateway, and private is internet access via net gateway. So let's create a net gateway first. Let's create the route table first. You can create any one, please. So let's create the routing server, route table, and create route table. We are going to create 2 route table. One is for the private, one is for the public one. So let's create the first public route table. RT is for route table alias we are using. So click on the create route table. Okay, our route table is created. Let's create the private one. Click on the create route table, private RT. Keep it same name. This is for the demo VPC. So route table is created. One is public one is private one. Let's public one make it public actually. For that, it is currently in the local network. Local means it is inside the VPC network only. So inside VPC, it can access any other resources which is created inside the or the in the same VPC. So first we have to associate with the subnet. So we have a 4 subnet available. So click on the edit subnet association, and these are public route tables. So select the public subnets. I've selected both subnet and click on the save association. So subnet are associated. Now go to the route table and click on the edit route, and here you have to add the route. For internet IP, you have to give the anywhere IP, that is internet ID. Now you have to select with the internet gateway. Click on the I have not selected the internet gateway. I have created one. Now click on the save changes. See, this subnet has directly access of the internet gateway. So that's what I shown in the diagram as well. It has a direct access. Okay, but for the private one require the net gateway. So let's create a net gateway. Click on the net gateway, create net gateway, means click on the button of the create net gateway and give the name demo ngw net gateway. It is the alias. We will create the zonal one. So as you can see the diagram, net gateway is created into the public subnet, not the private one. So let's select the subnet. We have a demo public subnet 0102. You can choose anyone. I'm going with the public subnet. Now you have to allocate the elastic IP. It requires the elastic IP. So click on the allocate. So elastic IP is created. Next, everything is default. Now click on the create net gateway. So net gateway is created. State is still in pending. Meanwhile, let's go for route table, the private one. So this is our route table private one. We have to associate the subnet. So we have a 2 private subnet. Click on the edit subnet association and select the private one. If I choose the public one, so it will associate, but we got the conflict. Now we have to edit the route. Click on the edit. We have to add the route. Select the anywhere IP, but the internet access not should be direct via internet gateway. We have to choose the net gateway. So here is the net gateway. Select this one. I think created. So selected. I have selected the net gateway. Now click on the save changes. Okay, so it has the access via net gateway, means two private subnet, and the public one has the access of the internet gateway. So our configuration is done. Like you can see, we have a public and the private subnet. We have created the VPC, we have created the internet gateway, we have created the route table, and do our logical configuration as well. So I think it's all done. So that's how you can configure your VPC. Let's click on your VPC and then open your VPC, and you got the scroll down. Then you can check the resource map. We have a demo VPC and we have a 4 subnet, 3 route table, 2 are configured, 1 is not in use, and then we have a network connection. If you select the internet gateway, it has the public route table, and public route table are mapped with the public subnet. If you select the net gateway, then it map with the private subnet. And if you want to check how private subnet are secure, so you can open the net gateway via here as well. Click on it. So our net gateway is loading. Yeah, it's open. So you can check it is created into the public subnet. So net gateway is not getting the access or exposed directly to the internet. It is created into the public subnet, and via that it get the internet. So that's how public subnet is secure. Alright, so this was the complete setup of a production level VPC architecture. Now you understand how VPC work, how subnet are designed, and how traffic flow via route table and the net gateway and internet gateway as well. And this is just the beginning. From here we are starting a complete AWS network series where we will go deeper into real world concept step by step. In the next video we will cover other topic like VPC peering, endpoint, and real production use case. So make sure you follow our series, because by the end of this video you will have a strong understanding of AWS networking that's actually used in real companies. Let's meet up in the next video. Thank you.